Thank you, everybody, for taking the time and coming to our talk this afternoon. I'm very, very excited to be here, and especially showing you the new cool features that we have in store for you in the globalization area. My name is Yaniv Feinberg, and together with me, I have Eric Fortune, who will later on talk about multi-user interfaces and deployment. So before we go specifically into the talk, I would like to talk about why globalization really matters. From our data collection, what we figure out, there are two numbers that are very important. There was 90% and 70%. What we found out is that about 90% of the world population today does not speak English at all. So you would like to have your application worldwide ready, meaning should be able to input and output text in a non-English manner. The other number that we found out that became very important is the 70%. 70% for us, so by the next year, most of the software revenue, about 70% of the software revenue will come from the international markets. Therefore, your applications will probably want to reach those markets in a globalized way. So how do we go about it? So when we looked at Windows 7 and those facts, we tried to find out what we can do for you. We have a very long history in Windows on providing globalization APIs. It started with us providing some basic information like text services, text layouts, date and time formats, and we did sorting for specific locales and so forth. But we finally reached the point that we can take it to the next level and pushing some advanced linguistic services that I'm going to show today in the slides. And after you have those applications enabled for globalization, you will probably want to deploy them in those markets. It was very difficult to deploy them in the past, as you had to create different type of packages depending on the market you were targeting. So creating a multi-user interface in a single package becomes very, very important. It's important from a deployment because it makes it easier to test and verify, but it's very, very important to the OEMs as well. OEMs find it very, very hard to deploy different type of packages depending on the markets you are targeting. So they actually really want from us and from you, if you can provide those packages and put them inside just as a one package, it becomes very easy for them. So I'm going to now focus on the advanced linguistic services that we're going to introduce in Windows 7. And later on, Eric is going to talk about the deployment and the multi-user interface. So in Windows 7, we try to identify the gaps that exist today and see how can we improve on those gaps later on. So the first gap that we identified is that applications or the developers really want to know what's the current user language that the user is using, what's the input or that is typing in or what he's actually reading in. And when you know that, you can tailor the user experience to that user. In the past, you had a very hard time doing that because the only thing that you can really rely on is kind of the system settings. For example, you would look at the local user setting, the system locale, or you try to find it out from the current input language. But it's not that informative. So if you know the language of that user, you can tailor your experience to that user. The second gap that we identified is that more and more international markets are starting to use computers, especially the emerging markets like China, India, or the Eastern European countries. And having that, you probably want to tailor your application into those markets in order to penetrate them, and by that, increasing your revenues. So, and that's another thing that we try to target. And finally, what we really wanted to do is to provide all these services and future services that we're going to provide later on in a very small set of APIs, making it very easy for you to learn. And the moment you learn that, then you can deploy it. And as we add more and more services, you can still call exactly the same APIs later on without the need of learning that in the future. Also, if you had to do it yourself, you probably would have created different sets of APIs, and that makes it just more cumbersome. So what did we do in Windows 7 based on these gaps? So what we provide is we build a platform that we call an extending linguistic services that provide this small set of APIs, making it simple and simplistic. And then we try to look at services that will kind of answer those type of gaps. So the first service that we're providing is a language detection. A language detection is basically when you pass text to us, we'll guess and try to tell you what language that user is having this text in. The second service that we provide is script detection. Script detection is basically the writing system or the alphabet that the text is written in. So for example, if I look at a Chinese language, even though it's a one language, there are two types of writing systems. There is a Chinese simplified and Chinese traditional. So even though there are two different writing systems, they still speak the same language. Another type of a language like that is Serbian, for example. So in Serbia, they still speak Serbian, but they write in Cyrillic and Latin. So there are two different writing systems. And the last service that we provided is the transliteration piece. Transliteration is a component that basically changed from one writing system to another. So when I mention Chinese, for example, you can think about it to translate simplified Chinese to traditional Chinese. And again, one of the most important things that we have done, we put all those services under the same single platform. Basically, it's just one set of APIs that you will need to learn, and then you can just call all the services and any new services that we're going to provide in the future. And if it's going to be us providing that, or later on, we're going to open it up for letting you guys provide services yourselves. OK, so let's dive into each service in specific. So the first service I would like to talk about is the language detection. And language detection and like script detection, I'm going to mention it in the next slide, are basically the foundations of providing an advanced linguistic services. You can think about it that the moment you know the language, you can tailor the application's experience to that user. And the reason it's a foundation is because the moment you know the language, you can then use that information in order to tailor the other services that you provide and do something with them. So for example, if you are developing a word processor, if you know the language, you can now call specific word breakers or proofing tools. Another thing that you can do if you're building a search engine, for example, the moment you know the language, you can tailor and go specifically to the right indexes, making the time faster. Or if you're providing some ad content or messages, the moment you know the user's language that is actually trying to write it or read, you can tailor the language of that message to that user. And when we provided that service, what we really wanted to do is provide that service and make sure that the language detection will work for every language that we provide a locale for. And today inside Windows, we provide more than 100 languages. So this language detection works for all of them. Another good thing that we've tried to make sure that this component works for is the fact that it will work for a mixed script environment or mixed languages, as I'll show in my demo later on. And of course, we wanted to try to make it as short as possible. That means it becomes more interesting, right, if you can detect the language in a very short sentences. And we found out that we are pretty good even in a sentences as short as 60 characters. And again, this service is provided under our platform, which I'm going to describe later on. The next service that we provide is the script detection. Script detection, as I explained before, is basically detecting the writing system or the character that this is categorized in. And some scenarios that you can think that you can use it for is basically, for example, if you know the script, you can then look at which fonts contain that script and then just show that set of fonts instead of showing a very long list, so you can be smart in fonts. Another thing that you can do is prevent spoofing. And this is actually something that is used today in Internet Explorer, for example. Spoofing is where you have two glyphs or two characters that look exactly the same, but yet they are coming from two different ranges in Unicode. So an end user, when he types a URL, it looks like it's actually going to the URL he intended, but yet he's actually going to somewhere else because the characters look the same to him. And then when he goes there, if it was a spoofing, somebody registered that and he can do some throat things. So when you look at Internet Explorer today, the green, yellow, and red line that changes in the bar is the thing that does that. So what he tried to do is looking at the URL, and if you have multiple scripts, we believe that then, therefore, it's a spoofing, and we change the risk level from green, yellow, and red. So, and how do we do that? That's actually relatively easier to do because Unicode is actually defining a script per character. So each character is actually, so what we do, we scan the text, and then we return to you for each character the script that it's actually encoded in. And we do that by ranges. So if all your characters are from the same script, we'll just say, for that range, this is that script, and for that range, it's that script, as I'll show later on in my demo. And one of the things that I want to, again, mention is that those are kind of scenarios that I'm mentioning, but you can come up, of course, with your own, right? It's just to give you an idea of what those scripts are. So with that, let me quickly show you a demo of how that works. So what I have here is a small application that we wrote where this part of the text box is basically text that you can type in to see what results we can come up with. On the right side of this is basically the scripts that we detect. So we're calling our APIs and then detecting the scripts. And on the left side is our guesstimate of the languages. And it goes by the guess of the likelihood, right? So because it's guessing, we're giving you the high probability first, following by the less probabilities. And for most applications, what they'll just do, they'll pick the first one. So let's start with some simple text, and I'll take, of course, right, the first simple test is just Latin-based pure English, and try to detect that. And as you can see, right, we just say that the whole text is written in a Latin script, and the first language we detect is English, as that is an English text, following by the likelihoods of the closest different languages, right, that we have, the closest distance. And one of the things that we can try to do is to see how short we can detect that. So I think we can do that pretty well, even if you go to a short sentence is up to that, like if I write just I should, as you can see, it will still detect that as English. And it's actually because most of it is English, now we can really say this is really English as opposed to try to guess, and other words that might be different languages we don't show, we actually say it's really English. So let's take a different language. In this case, it's French, but yet still written in the Latin script. So if I pass the French text, as you can see again, it's all written in Latin, but yet the first guess that we're guessing it's French, following by the most likelihood, again, from a distance of the languages, and therefore in that family you see the Catalan is next, and Spanish, and so forth. Okay, so now let's try to take something more complex outside the Latin script. So in this case, what I'm doing, I'm taking the Indic script and trying to detect that. As you can see, so all the scripts written in the Devanagari and the language that we detected is Hindi, following by Marathi language. Now, what's interesting about them is they are actually very, very close in distance. But yet we are doing a pretty good job in detecting that. Even if I take the next test here, which is also written in the Indic script, basically the Devanagari script, and I try to detect that, this is actually written in Marathi, and then our next guess is Hindi. So it detects that pretty well. But what happens if we actually have a different language that is written in multiple scripts, like in the case here, and we try to detect that? So as you can see here, this is all written in Japanese, but yet we are using two different writing systems, different scripts. So the first part, as you can see here, this is kana, following by hani, following by kana again, and so forth. But yet we see that even though they are written in different type of scripts, they're all written in the same language, which is Japanese. Now, the next thing that I wanted to show is what happens when you have two languages written in two scripts, like in this example right here. And I try to detect that. So as you can see from here, the first part, the first script is Hangul, which is actually Korean, and the next script is Devanagari, which is actually Hindi. But yet, if you look at our language detection, we kind of detected the opposite, where we're saying that the likelihood of the language is Hindi, following by the Korean language. And the reason for that is what we're trying to do is to see as a paragraph as a whole, what language do we have more? And we see here that if you look at the high level of that paragraph, it has more Hindi, and therefore we treat that paragraph as Hindi. But this is where you can actually take our services and try to change them and then become more accurate. So one of the things you can do, you can run the script detection and break that and send those to the language detection pair ranges. So for example, if I take only the Devanagari script and I say detect that, so as you can see, I'm going to do detect on just the selection, it will say this is Hindi. So you can go and break those two scripts first, and then if you pass it through our language detection, you become more accurate results because of that. So with that, let me move back to the slides and talk about the other services that we have. So the next service that we provide to you is the transliteration. Transliteration is basically a tool that allows you to write and change from one writing system to another. One of the and we can do that. So the transliterations that we provide is simplified to traditional Chinese. We also provide Cyrillic, Bengali, Malayalam, and Devanagari to Latin, and so forth. Few scenarios that you can immediately think of is it helps communicate between two people that are actually writing into the writing system. So if you think about a Chinese user, it can now be able to read from different type of content. So if you go to a website, you can go to a website that was written in a different script and then converts that, and now we'll be able to read this content. Or if you use some other tool of communication, like Instant Messenger, now two people will be able to communicate, as in the transparent, you can actually write something that will convert it on the fly. And actually, let me show that as a demo. So let me quickly close that. So I set up my Instant Messenger with my friend Encarta, and I'll try to communicate with Encarta here. And before I do that, what I want to do is to invoke our demo. Now, the reason I'm showing you that is because after the talk, we're actually going to provide to you all the demos so you get to play with them after the talk, and we also provide you with the sources for this tool, so you get to see actually how we actually implemented that, and you can do something similar as well. So let me just quickly try to get a Chinese text for it. And since I don't speak Chinese, or I don't write Chinese, it's easier to do it this way. So let me ask Encarta, my friend, if you can speak Chinese here. And as you can see, it comes back with some text here. So what did we do and show here in the demo? So the first thing, this is the text. Actually, let me see if I can show it bigger. Right. But before doing that, let me increase this. Okay. So the top part, as you can see here, this is basically the text that was passed to us. And as you can see here, we detected that this is a Hani script. But because we have the language detection, we can even tell you that it's not just Hani, it's actually Hani written in simplified Chinese. And because we know that, we can know now which pairing of transliteration to call. So since it was written in simplified, we can use the transliteration and call the traditional one. So we're doing the mapping between simplified to traditional. Much in the same way, for example, in our tool, if you pass to us Cyrillic, we'll do a similar mapping, and we'll go from Cyrillic to Latin, just because we can. So it's just another way to do the chaining between script detection and language detection. So as you can see here, we detected that the script is simplified, and therefore we called the simplified to traditional Chinese. And what you see below that is basically the transliterated piece. And you can tell that this is a traditional because it has more strokes. It's more complex. So if you look at the second character here, you can see it has more strokes compared to the character right here, which has fewer strokes. So this is pretty much how the transliteration works. OK, so this is pretty much right what services we provide. And with that, I would like to move into talking about the platform itself. So the services that we provided are basically the foundations of building an advanced linguistic services. And we'll provide more and more as time progresses. And because we know that this is just the beginning, or just the touch of the iceberg, and we wanted to create a platform that will be easy for you to use. So therefore, we try to come up with a simplified platform where you have a very small set of APIs, and that way you'll have just a tiny thing to learn. And actually, we have about 4 to 5 APIs really that you'll need to learn in order to call those services. And the second thing, of course, as I mentioned, is the scalability. Because will come more and more services over time, will want you to still call the same APIs and get that without actually learning or needing to understand the internals of each service or how that works. So how did we go about doing that? So the first thing that basically the way you need to call us is the first thing you do, you basically call enumeration. And the enumeration will return to you what type of services we have right now on the system. So in Windows 7 right now, we'll return back that we have 3 services, the transliteration, language detection, and script detection. And then, you decide, or you want to pass text to all the services or specific services that I'll show later on, and ask the services to recognize the text. And what he will do in end, he will go and each service will scan the text, see if he can do something with them, and then return results based on those services. OK. So let's look at just each API in specific. So the first API is the enumeration. And the way we're calling it is the mapping get services. And we implemented a filtration on top of that service. What that means is that you can call this API and say, just give me all the services you have. Or you can say and become very specific, as each service has some properties associated with it. You can go and ask for something in specific. So for example, give me all the services that accept or return plain text, or give me every service that returns text in Japanese, or every service that has an input script that accepts Latin only, and so forth. Right now, you probably will not need to use that, or you will probably call a very specific API using its GUID. But in the future, as we provide more and more services, you probably will want to use that. The next service or API that you will call is the recognize text. And the way we're calling it is basically, say, map recognize text. And the way you do that, you just pass this text to our platform, and you tell it which services to use. When you do that, the service then will return back results to you and say, OK, I don't recognize this text. I can't do anything with it. Or this, if it's let's say a language detection, will say this language is in German, as you saw, or give you an ordered list and so forth. Or this language is in a certain script and so forth. So if I'll go through a flowchart of how does this thing happens, basically the application passes some text after enumerated. And in this example, we'll say, here's a Russian text, send it to all the services. The platform then takes that text and sends it to every service, and then each service returns results back. So for example, the first one will say, this is a Latin form of Russian text. This script is Cyrillic, and the language that I detected is Russian. And then, of course, in the future services, we'll do some more things. Or if you'll provide services to this platform, then it will do whatever you tell it to do. Right. And then and another way you can say, is just, I want specific service. So for example, it's exactly the same flow, but now you say, just go through transliteration. And in this case, it will just return the Latin form. OK, so this is pretty much in a very high-level overview of this platform. And the things that are very important to remember is that ELS is very, very easy to use. It has very few APIs that you need to learn. The language detection and script detection are really the foundations of advanced linguistic services, and building those and using them will give you an advantage. And you can tailor the information to that user, which is really the key of why you need those, right? Because you really want to tailor it to the user. The transliteration service will help you penetrate into a new markets like the emerging markets and provide that and cross these communication boundaries. I showed you, like if you take the Chinese, for example, you can then cross boundaries between two people that speak the same language, but yet writing into writing systems. Another thing is, as I mentioned before, we'll add more and more services as we go on. And therefore, you can just keep a watch on what services we'll provide, but yet you will not need to learn new APIs to call them, because we'll basically use the same APIs, and you can just call them or not. And just try ELS and tell us what you think. Now, and before I hand it over to Eric to talk about deployment and multi-user interfaces and how you can take advantage of after you have an application written globally, one thing I want to mention is that since we have the sources, if you really want to see that really the flow of the code is really the same between each service and there's no difference, we can show it later on after the talk right, if you care to see exactly how this works. But really what you can see there is that if the moment you know one service, it will be exactly the same way as calling the different service. So there is no difference. And with that, I would like to hand it over to Eric to talk about deployment and multi-user interface. Thank you. You on mine, Eric? Here, take mine.
Sorry about that. Can you hear me now? Okay, my name is Eric Fortune. I'm the lead developer for multilingual UI, multilingual user interface in Windows, also known as MUI. Feels like I'm quiet here. Can you hear me back there? Also known as MUI or sometimes called MUI. We use them kind of interchangeably. And I'm here to talk about how you do that in Windows. So first of all, let's talk about why multilingual is important. So there are a couple of benefits to multilingual from sort of your point of view as someone shipping applications or our point of view as shipping a system. First is a single worldwide image. If you have a single package that you ship around the whole world, you only have one package to service, one package to ship, one package to manage. It's much easier to deal with than if in Windows XP we ship 24 different languages, which meant for servicing, if we shipped a patch, we had to ship 24 different patches, and we had to make sure the right patches got to the right machines. That was an issue for us. It's really an issue for people who are trying to deploy Windows. I'll talk about that in a minute. And then finally, also, the user experience is also much better. If you can have users who use different languages share a machine, or for multilingual users, some prefer to do some things in one language and others in another. I run with a German UI most of the time, but I prefer developing in English, and can't do that without a multilingual desktop. So a little bit more on single worldwide image. This is, as I mentioned, it's a big benefit for us. It's really a big benefit for people deploying Windows, specifically for OEMs and for corporations. So they rely on image deployment, starting in the last release, and they're relying more and more on multilingual deployment. It reduces the number of images they need to manage, they need to maintain, the number of images they need to patch when a new patch comes out, the amount they need to distribute. It's a huge cost savings. Just for us, as I mentioned, we went from 24 different packages down to one. We have now the core operating system is completely language neutral, and based on what we've seen, it's something like 85% of all of our patches are completely language neutral, which means we reduced the number of patches we need to build, test, and distribute by an order of 20 or something like that, which is huge. So it's huge for us, huge for OEMs and the enterprises. The problem for the OEMs and the enterprises is that it only works if everything on the system also is multilingual. It doesn't work if the operating system can be changed, but the applications don't follow suit. As a result, OEMs and corporations, enterprises, are really starting to demand that anything that's going to be pre-installed on an OEM image or on an enterprise image be what they're calling MUI compliant or MUI compliant, which means really that it has to play well in an environment where they're shipping a single worldwide image. We're getting this directly from the OEMs and from our enterprise customers. We're also hearing this from developers. I've had generally things that ship in box, like the hardware support applets or things like that. We've had developers knocking on our door saying, "How do I get MUI compliant?" Because they're really being asked to do that. So the first question is, what is a multilingual application? And it's really, for starters, it's a properly globalized application. Excuse me. That means you use all of the proper locale settings, calendar, all the stuff that's built into the system to be a properly localized application. Use ELS for your text services. I should mention here, if you're developing new applications for Windows 7, there's a new API Direct Write, which provides very high quality rendering for various scripts. That will be covered in more detail in the session tomorrow, PC 18. So you can look that one up if you care. But For starters, you have to be a properly globalized application. And then the next thing to worry about is how does this thing deploy and how does it run? And it needs to be able to have multiple languages installed at once, which means the resources can't be built into the main binary. It has to follow the rest of the system. It doesn't really do any good if the system is going one way and the apps are going another. It can be deployed properly in some of the imaging scenarios, and can talk in more detail about that. And as I said, this is MUI compliant. So if you have OEM or a corporation or somebody coming to you and saying, please make your apps MUI compliant, or sometimes they'll say MUI compatible, this is really what they're talking about. And that's a little confusing because MUI or MUI is also a technology. And that technology consists of a bunch of common settings for choosing your UI language, which didn't, when we had a single language system, that didn't really exist. And those are at the system user and the application level. And then there's also some extensions to the Win32 resource model to allow satellite-driven resource loading, which makes it possible to ship multiple languages side by side. And so very simply, a satellite model prior to MUI, so XP or before, we had every version of the operating system had some common code, and the code was really the same for almost every system. But the resource section was changed out with the appropriate language. Changing those resources out is a post-build process. We didn't have to rebuild or reship everything, rebuild the code pieces when we reship things. But we did have to go relocalize everything, redistribute, retest, the whole 9 yards. So starting using MUI, those resources were pulled out into a separate MUI file, which is just an executable. And now we ship a single language-neutral binary that contains the code. It also contains language-neutral resources. And all the resources are, all the localizable resources are pulled out into separate files. Those can be added or removed at will. We can service the main file without affecting the satellite files and vice versa. So that's when people think of the term MUI, they generally think of the satellite resource model. Another important piece are actually the settings behind it that make it work. There are a bunch of settings for system user level, application level things. They fall into two categories, and it's more important to understand the categories and the exact details. The first category are the system and the user settings. Those settings are used by the system itself for all of the system UI. Those must be installed as system languages. So you cannot set the user or the system language to a language that has not been installed as a system language. You get a single setting for each of those, with the exception that some languages are only partially localized, in which case you also get to specify your fallback languages that will be used for things that aren't localized. For example, Arabic can fall back to either English or French. Catalan falls back to Spanish or French. And you get to choose, that's obviously a user preference, which way they prefer to go. These are set via the the regional options control panel, and there's no public API for setting those. The application UI languages are not stored by the system anywhere. They must be set by the application. It's a list. It's a multi-string, null-terminated multi-string, double null-terminated multi-string of up to 4 languages. And these languages need not be installed as system languages. So you can install an application with different languages than the underlying system, set the languages you need as the either process or thread language, and all of your resource APIs will find your resources automatically. And you can set fallback as well, so you can do partial localization just as we do for the system itself. So how this works, these languages, all the settings are essentially composed, and you don't really need to know the details of this. They're all composed into a list. And here's a list of all the settings. You can see they're all composed together into a list, and then we remove duplicates, and we insert parents. So there's our duplicates. The parents are already inserted. And in the end, we end up with this fully merged preferred UI language list, so a long name, which is the exact order that the Win32 resource loader will search for resources in external files. So if you ask for a string or an image or an icon using load string, load image, load icon, any of those, we'll first look for a French file, then for a Spanish, German, Arabic, English, and finally Catalan in that order. That's important later when we talk about how you can play along with MUI if you're not using Win32 files. So the next question a lot of people have is, how should I use MUI technologies? So if you're writing new Win32 applications that will be using Win32 resources, just use MUI from day one. And it's not a whole lot to do except in the way you build it. Make sure, verify that your packaging works for multilingual deployment. We'll have some tips on that in a little bit. And rely on the OS resource loader for fallback. A lot of applications written before the system had this capability will do explicit probing for whatever their application languages are. So first I'll look for Hebrew, and then I'll go get whatever's on the system. It's important to not do that. Instead, you want to set your processor, your thread language, and then get the list back from the system. That will get you the proper fallback order, and that will get you consistent behavior with the rest of the system. If you have existing Win32 resource using applications, you want to migrate them to MUI wherever possible. If you have non-Win32 applications, and this is also native applications that are using other resource models, you want to make them MUI compatible, and I'll talk about also what that means in a little bit. Existing localized applications work on Windows 7 and on Vista just as they do today, but we have all the deployment and servicing issues that I talked about, and it leads to pretty bad user experience. And so, which leads us to our recommendation, which is focus on the user experience. And you really want to be sure that your applications behave the way the rest of the system does and the way the user expects it to and the way that the OEMs and the enterprise deployment teams, IT teams, are expecting them to behave. And that means package your code and resources separately, make sure that you deploy cleanly, and load your resources the same way the operating system does. So now we'll go a little bit into the details of how you create MUI files. Frankly, it looks a lot like creating a resource file for Windows itself, for existing Win32 applications. You define your resources in an RC file just as you do today, and you make literally no changes. There is a new RC configuration file, an additional XML-based file, which tells one of several tools how to split the resources. Which resources go into the main language neutral file and which resources go into those satellite MUI files. I'll have an example of that in a minute. There are essentially two tools that you can use that consume this RC config and that will split resources. One is you can use the RC, our old friend rc.exe, the resource compiler, has been extended to read these config files and produce two output resource blobs instead of one. Or you can use a tool called MUI RCT, which will essentially edit an existing binary and produce two files. We'll take out the resources that should be localized and create a new MUI file. And then you need to make sure those get installed where the resource loader expects to find them. So the RC config is a pretty straightforward format. Basically, the important piece is the localized resources section there, which tells the resource compiler, or MUI RCT, which resources go into the satellite resource files. Any resource, by default, any resource that isn't specified stays in the language neutral file. Anything that's specified in localized resources goes only to the MUI file, to the satellite file. It does not stay in the main file. And in certain cases, you might want to put a resource in both places. So there's also a neutral resources tag, which allows you to put to specify that one of the resources, which is localized, should also go into the neutral resources. In this case, we're specifying type 16, which is the version resource, which has to be in the file to get it loaded. The other thing to note here is that you can specify resources by type, which is the most common way to do things. Just put all of your strings in the resource files, but you don't necessarily need to. You can also specify resources by ID to be split. Right? So for the type name 2, we put specific items in the localized resources. Any other type 2 resources that don't match one of those IDs or names will end up in the language neutral main file. So how do I go about localizing my application? You have essentially two choices. You have source localization, which means I create separate RC files for each language, and then I rerun the RC compiler for each and every language, generate an MUI file, and off I go. I can ship those. That is relatively easy in that you need no new tools. You can do this with Notepad. But it's also relatively hard in that the RC format does not lend itself well to being handed back and forth for localization projects. It's not a structured format at all. It's very easy for small changes to introduce differences that really confuse the process, right? So this isn't really automatable. If you expect to have several iterations, or if you expect to have some UI churn, you'll do a lot of extra work just keeping up with the RC format. Works well for small projects. You don't need to learn any other tools or anything. PE file, so portable executable file localization, means actually editing the MUI file. So I do something to generate a MUI file with the contents I want, and then I run another tool which takes data typically from a translation memory from some other database and replaces the resources in the generated MUI file with another MUI file, and then off we go. And then you localize the MUI file. The thing to note about this is an MUI file it looks pretty much to all tools, looks like an executable with a bunch of resources in it. So if you already have some sort of PE file-based localization process in place, the MUI files will drop right into that. There's no need to do anything different except recognize the extension as a kind of file that you can edit the resources in. So we'll just walk through these really quickly. So again, for source localization, I start out with a number of localized RC files. And when I build the application, I pass the RC config file. The resource compiler builds 2 sets of resources. We link 2 sets of executable files, and off we go. And then when I want to build another language, I just go follow that bottom chain again. When I want to build a third language, I run that whole bottom chain again. Pretty straightforward. So for PE-based localization using the resource compiler, you start out with one resource file in whatever your source language is. For us, that's generally English, but it can be any language. That's up to your process. And you build, again, using the RC compiler in pretty much the same way. The RC config produces 2 files, one language neutral executable, and the mother of all MUI files. Now, to localize, all you do is take that MUI file and pass that off and edit that file. And that can happen in a post-build process. It can happen offsite. It can happen anywhere. This is pretty much the way we do things. It works very well. You basically get things from your build and emerges something that you can immediately get to work on and start localizing. It does require changes, typically in the build process itself, to handle the splitting up front. It lets you put your configuration near your source, which always makes it easier to keep things in sync, is a big advantage. And then finally, the last sort of lowest touch way to do this is to do a complete post-build process using the MUI RCT tool. And the way that works is you build an executable just like you do today. That's not split. So all of the resources are in the executable. And then in some post-build process, I pick up the RC config file. I run this tool, MUI RCT, which splits that file into a language neutral and a satellite file. And then I just localize that satellite file for every language, just as I did in the first process. So this is the lowest touch. You can do this in completely post-build process. However you're building your application today, you don't touch it at all. This is something that runs completely afterwards. There's a little bit of management overhead in having to keep the configuration in source with the source files, but it's not too bad. So now you've managed to build these things. Some things to be aware of when you're trying to deploy them. One is be aware of the installed languages that are on the operating system. You probably want to install, by default at least, all of the languages that are already present on the system to the extent that you support them. You also need to be aware of the user's UI language preferences, obviously. You want the user to be able to see the UI of the setup application in the language they expect. But the thing that's really key is to be aware the language used for setup might be completely unrelated to what ends up happening on the user's machine. If this is happening in the OEM's build lab or on their factory floor or in some enterprise image, it could be a completely unrelated language. It might not even be the language the person installing the system using might not even be installed on the final image. So don't write things to the registry at install time. Don't copy just one language of things. Don't assume that because you're being installed in language X that language is going to be the one you have at runtime. That's really important. And then also, just to reiterate, note that when you think about servicing these things, if you're only servicing the executables, you don't need to touch the resource files at all. And so that simplifies things a lot. Loading these is completely transparent. So all of the resource APIs, load image, load string, find and load resource, all transparently now search actually in Vista and beyond, will transparently search for satellite MUI files, look in the resource files for look for resources in external satellite MUI files if there is an RC config, a compiled RC config in the main executable. It just happens. So if you've built your MUI resources using any of the processes I talked about earlier, then we'll find your resources. You don't have to change a line of code. If you're already doing some application-specific probing for an application language, you have a setting, you want to be able to do something different than the language, you do have to change the code a little bit. Again, we don't recommend doing your own probing because there's all kinds of fallback stuff that happens in the resource loader itself. It's much better experience overall if you call the new API set process preferred or set thread preferred. The difference is, I hope, obvious. Call the appropriate language to add your settings to that entire fallback chain, and then use the fallback chain to find your resources. So this covers Win32 resources. The reality is applications come with a lot of other things that are resource-like and are language-specific, but they aren't really resources. So a lot of applications use registry strings, and that's one of the things I talked about. Don't copy registry strings based on the install language, the language at the time of install. Shell shortcuts, help files, the event log if you generate any events, group policy for corporate applications, for enterprise applications, WMI. All of these things are forms of resources. MFC uses a similar satellite model, but slightly different. Every technology has unique requirements, so you have to figure out how to make these things fit. We have some tips in general. And some resources in the appendix in the slide deck. So when you get your hard drive, you'll have the materials. We have some specific details on these technologies and a pointer to a site, a Go Global site on Microsoft.com, which has a lot more information, a lot more background information about these things. Specifically for MFC resources, I don't think it's up yet, but we will shortly be posting some sample code that makes it very easy to make MFC applications follow the system fallback logic. By using one of the techniques I'm about to talk about. So there are basically two techniques for taking your resources from some other technology and getting them to be consistent with MUI. And the first, and this is kind of the heart of MUI compatibility. When you talk about making your things MUI compliant, it doesn't necessarily mean changing everything to use MUI files. If you're already using resources, that's probably the easiest way to go. But if you've created some other mechanism for whatever reason, you can continue to use that mechanism. You just want to make it cooperate with MUI. One technique is redirection. We use this for registry strings. As I mentioned, a lot of applications have written registry strings, usually at the time of install, with specific strings, and then they read the registry to get that information. So one technique is to replace the string in the registry. Instead of putting a language-dependent string there, we put a reference to a DLL and to a specific resource ID. And then at runtime, we change the call from reggetValue to regloadMUI string, which goes out, parses that string, says, oh, I need a string from that DLL over there, loads that using MUI, and you get 100% consistent MUI fallback. Now, you need to move your localizable content into DLLs, and then you can localize them using your entirely consistent process. Shell shortcuts, some INF files use similar redirection, so this is a pretty common technique for a bunch of things. There's a couple of cautions. This has some interesting interactions with resource-only DLLs for rarely used strings. So we actually had a case in some of our early development where we had an application that was reading 700 of these registry keys, one after the other, but they were in a resource-only DLL that wasn't loaded, which meant that for each and every string, we loaded the DLL, we loaded the MUI file, we read a string, we unloaded everything. And then we loaded the DLL, so we had 1,500 image loads, which was a huge performance hit. In the normal case, the answer was to just move those to an existing file. If the files are loaded, which is the 99.9% case, the overhead is really not detectable. And then the other technique for making your applications be MUI compatible or compliant is to do your own probing. And so we have a couple of helper functions to do that. The first is getFileMUIPath. GetFileMUIPath allows you to pass the name of a file you're looking for, and we will search for that file using the fallback list that I described earlier under the current directory, or I think under a path you pass in. And so that's a very easy way to find if you have XML files or some other external form of files. That's a very easy way to find it, and we'll just do all the probing work for you. If that doesn't work, then you need Am I live? Can you hear me? Good. So you can get that thread, that fully merged list that I mentioned earlier. You can use get thread preferred languages to get that. There's a combination of flags you need to pass in to get the full list, and then you can just walk each element in that list and use whatever probing logic you need. And the MFC sample code that we'll be putting up does precisely that. And in fact, it translates. MUI uses the system locale, the EN-US, right, the ISO-compatible naming. MFC is typically used 3-letter names, so DEU, et cetera. The sample code actually uses the locale APIs to convert the languages, and so it will find your existing satellite DLLs, but it will do it in a way that's system compatible. And so that's, for MFC apps, that's a good way to go. And then again, just to reiterate, if you have your own language settings, and you want to set those, please use set processor, set thread to set those for the application and use the resource loading APIs. Don't do probing a couple of different ways. That just leads to really subtle, weird inconsistencies depending on where languages land in the fallback list and leads to a kind of odd user experience. Wrong way. Few other things to think about as you're doing this. One is backward compatibility. We provide a couple of APIs, a libraries, load MUI library and free MUI library. These are shipped as part of the SDK. You can take them down level, and they let you build an application in a way that works on both XP and on Vista. Obviously, XP doesn't have all of the settings, so you don't get the full MUI experience, but you do get consistent fallback with the rest of the system and the ability to create one package. And for console applications, if you're writing console applications, there's some script limitations. The console can't display every language. Just be aware, if you take a look at any of the MUI documentation on MSDN, it will tell you there's a few flags you need to set. You need to make sure your code page is set correctly, and then we'll handle the resource fallback appropriately. So if you have applications that are a mix of console and UI or whatever, you can set Hindi, or if the system language is Hindi, and we'll figure out that we need to fall back to English or whatever language is appropriate. And then it's generally a good idea because of that, because the language on the system might not actually be possibly be displayed in the console. For console apps, we generally recommend building a multilingual binary with a bilingual binary with in the main file putting the resources for some language that you know will display in the console, so that you always have resources regardless of what's installed. This thing, try that again. And that's pretty much all we have. Please, thought we had a question slide. We're happy to take questions, both of us. Do you want to come up? Yes, so as I mentioned in the appendix, a couple of things in the appendix. One, there's more details on all of the various other technologies or pointers to some more information. You have contact information for both Yaniv and for me, and there's a pointer to the Go Global site on Microsoft that contains a ton more information. It's being updated all the time. That's your one-stop shopping. That's the place to start. There are a couple of blogs linked off of there. I think the MFC sample will probably be going to Michael Kaplan's blog, sorting it all out. But there'll be pointers to it on the front page, and you'll be able to find it. So with that, if we have any questions, there's a microphone in the center. Why don't we just go to that? And please fill out your evaluations. Let us know what you think.
So our application right now is not using the compiled resource files, but it's using XML. And it was OK when there were 5 languages. But now going to 29, the size is a consideration. So what do you recommend for that? Without rewriting the whole thing, of course.
Without rewriting the whole thing, that's a tough one, because you're already, presumably you have some plumbing that's loading from the XML files. And that plumbing is going to have to change one way or another. If you're going to change it, I would recommend changing, so then see about changing it to MUI so that you don't have to own that plumbing from then on.
No, we are using we are looking up the culture and everything. So we are following the recommendation, except we are not using a compiled MUI file.
Right, so then, but you'll have to change, so your plumbing will change somehow, and the way I would recommend to change it would be to actually move things to the resource files. Now, it depends a little on what you're putting in the XML, right? So
the other question was, you talked about detecting the language and stuff, but the UI also needs to change. For example, if somebody changes the language from English to Hebrew or Arabic.
Right.
So is there an event that comes up, or does the user need to restart the machine in Windows 7?
If we're changing the system language, if you're changing the user language, you need to log out. If you're changing the system language, you need to reboot the machine. Within an application, you can mix languages. You need to make sure you get the right byte order marks in your dialogues to get your dialogues to flip appropriately. But there's a little bit of trickiness there, but you should be able to change on the fly. Now, there's no event to say, hey, the user just switched. All right, so if you switch your user language, you need to log off and log back on. But if you say you have an application-specific mechanism to choose a language, then you can trigger off of that and say, hey, refresh my whole UI, please. And when you do that, you'll get resources that contain the correct right to left mark, and will cause your UI to flip appropriately.
Okay.
So, and feel free to grab me afterwards, and we can talk about the specifics of your XML.
I have a question regarding the RC configuration file, the XML file.
Yes?
Is there any tool to help to construct, or we have to do manually for now?
You have to do them manually, but they're generally pretty simple. In fact, we use, even for building all of Windows, we use, for the most part, the same RC config file for almost everything. And there are a couple of template files for, we build, as I mentioned, console applications we build one way. Okay. Most applications share the exact same file.
Oh, okay.
And there are very few exceptions. There are a couple of cases where, an application has its images might be potentially localizable or something. So there are a few templates for applications, but we have a few checked into the build process, and then the apps just refer to the one they use. So they're not that hard to manage.
So basically, let me get it. Basically, if I have 20 resource DLLs, I can just construct one and make
generally, and that's why we generally do the type-based redirection. So we just say put the strings in the MUI file, put the images in both places, or put them only in the neutral, or put them only in the localized version, depending on what's appropriate. And then you can, once you're doing that, you can reuse those files everywhere. And we do that for, as I said, for almost everything. I think we have, like I said, a couple of templates. So we have apps with localizable images or not.
Right.
So that just says where the images go. Drivers are a little bit different. There are a couple of special cases, but we have a handful of files. We don't have a file, an RC config file per application.
Okay,
right.
Thank you very much.
We build the satellite resource DLLs and put them in the appropriate folders.
Right.
And we've been just setting the application's current culture. And when we do that, then the whole application switches languages and seems to work just fine.
Okay, so this is managed, though. This is .NET.
This is managed code.
So the .NET has from day one had a satellite model, and it works. The place where that gets interesting is the fallback rules used by the framework are not the same as the fallback rules used by the operating system. Some of the cases I talked about, for example, Catalan falling back to either French or Spanish, the framework will do something based on the language tags, which has nothing to do with the user setting because they have no way to know about the user setting.
So that's the advantage of using the MUI model
is
that your application follows the same rules as the OS then.
Right. And so, if you don't ship Arabic, the user will get either the English or French that they expect. They won't get something kind of picked at random.
Okay.
And we don't have anything ready to go right now, but I'm working on recommendations for managed apps, and we work closely with the folks in the BCL, the base class libraries. This is a problem we're working on, and we will get fixed. That time frame is the question, but I'm working on sort of interim ways to do this in your application as well, and
okay.
Those will appear on Go Global. If you drop me email, I'll make sure to ping you when they're ready.
Okay, thanks.
Yep.
Hello. I have a few questions about transliteration. The first one is, how do you agree about the transliteration rules? The second one is it possible to customize the transliteration rules? And the third one, do you plan to deliver transliteration functionality platform independently? That means, let's say, with .NET Framework 4.0. Thank you.
Can you repeat just the first question, please?
The first one was, how do you agree on rules? Because we have a business application currently in our company using transliteration. It was relatively easy to implement, but it was very difficult to agree on the transliteration rules.
Okay, so, well, transliteration is like any other linguistic service, right, requires a linguistic expert. And the way we evaluated that, so after we build the rules, we actually send it to the field. In this case, right, if you take Chinese, right, we send it to China to evaluate and get us results. And based on those and that feedback, we tailor that to the user experience. There are some linguistic specific for specific fields. For example, you can build transliteration for computers and so forth. But we tailor that to the more a global user, right? So we wanted to tailor it to an average. Our service allows you, and it theoretically allows you, right, in the future to provide multiple extensions to this transliteration. So you can add in more and more pairs, and therefore you can tailor them. So you can do it specifically for medical transliterations and so forth. But right now we have a generic for those languages.
You also have a way to pass properties in when you...
Right. And so another thing is that the platform itself, when you call us, we allow the user to pass specific settings. So for example, if you build your transliteration in such a way that will require tailoring or sending certain flags, you can then call that specific service with those flags if you extend that to that level. But currently, we do not do that. Okay. And regarding the .NET framework, it's like any. So we in the future planning to also add wrappers for the framework as well, probably in the near future, and therefore you can call it, or you can still call the native APIs today.
But the functionality will require Windows 7.
The functionality will require Windows 7 right now. Yes.
Okay. Thank you.
Hi. Hopefully a couple of easy questions. So first of all, we currently don't, we use the movie for testing those deployments, but people put whatever they put on their systems. Just want to make sure, those APIs that we could transition to, we do our own resource DLL, separate for each language, okay? Similar. You don't need the MUI system for those to work, right? Or
well, you need...
the end user doesn't have to have installed a MUI version of Windows for those.
So actually, starting even in the previous release from Vista and Beyond, there's no such thing as a non-MUI system. So it works.
Okay.
Vista and Beyond, it just works.
So it just works. Okay. That was just a little scary to think that. Okay.
Yeah,
that
no,
wouldn't work.
not at all. Just a little bit of background. Prior to Vista, there was something called MUI, which was a bolt-on to the XP system, and then bolting on MUI, reusing the name was a problem. Changed a bunch of things in the way the system works.
Okay, yeah.
From Vista and Beyond, this is the Win32 resource loader just works this way, and you get it for free.
Now, those APIs you talked about in the transliteration and all the languages, is that going to be published somewhere that we can see what those look like?
So in the Go Global, so basically when you connect to that presentation, if you go to the appendix and then you go to that website, we're actually going to document all of it, right? So it's going to be also in the SDK, but you'll also have our sample code, the ones that I showed you actually have the real code that you can use, and you can follow that.
And you mentioned Unicode 3.5. Are there changes in 7 about, I don't remember what version Vista was up to, or in terms of support, changes in the way
I don't actually.
translations from
one. I honestly don't know the answer to that one. Drop us an email and we can get but I believe we snap to the latest version.
Because of a lot of legacy data being character set based, we do a lot of conversion to, Unicode. So just want to make sure we get the same results. Right. Those kinds of things.
Yeah. Why don't you drop us an email? Our contact information is in here. I'm just Eric, ERIK at Microsoft, and we can point you to the right person.
Okay.
So.
Okay, let me give you a little background on our app. We're technically MUI compatible back to Windows 2000 and all the way forward.
Okay.
Because we put all our multilingual resources all in the same binary, because the 2000 XP MUI loaders have to find it in the system folder, and we didn't want to deal with that.
Right.
So my question is, we also have a shell extension that uses MUI resource loading. So it's obviously the operating system that's actually doing the resource loading. But we have languages that don't match up with Windows language list. For example, ENUS and ENGB.
Right.
So when you go to choose your UI language, there's only English or Spanish, whereas you guys split Portuguese and Chinese, but everything else is one language.
Right.
Are there plans in the future to allow the user to select the locale? Fully specified?
That's a topic of a long. So this is feedback we get a lot, and the part that gets interesting is figuring out how you fall back appropriately, right? If you hand me New Zealand, what do I look for next, right? Do I look for Australia and then GB, then right? So the fallback rules get interesting, or you go back to the neutral and you just have an English, but then you get into the what's English, right? So there's a bunch of complexity there. Ideally, we'd like to be able to handle that, and we certainly think about ways to handle that. One thing you can do in your applications, if you're shipping ENGB, is use that set process language. Those don't need to be installed system languages, and so you can choose the fallback that's appropriate for your app.
Which we do.
So you can say ENGB followed by ENUS, and then you'll get that for all your stuff. The system stuff will still use the ENUS, right? This is exactly why you don't want to do your own probing, by the way. Because if you call out to the file dialog box, you don't want it to pick something random. You want it to be somehow related to what your application is.
We do our own fallback, and we basically check the user's locale and their UI language. If the language matches the UI language and the locale, we take the fully specified user locale as the preferred. Then we go to the UI language.
Okay, yeah, we should talk about that.
Okay, and then I have a bug report.
That one
on
of that
resource loader, but.
Yeah, so there's a bunch of weird, interesting edge conditions when you start doing things like that. So depending on the languages, but particularly when you get to console and a bunch of other cases, it gets kind of weird. But feel free to grab me afterwards, and we can walk through it in more detail.
Hey,
we'll both be at the Ask the Experts tomorrow night as well.
I have two questions. First one is you mentioned that from initial 26 different binaries, we have gone down to one.
Yes.
And applications are MUI compatible. Now, I know Microsoft comes out with MUI packs very frequently, and Catalan was the last one. So when I have an application out which supports 26, now Catalan 27th came out, does that mean that my application is not MUI compatible anymore?
No, it means that you have, so you need to handle the fallback. There's a notion of an ultimate fallback. So you need to have a fallback language that you're sure is on the system.
Okay.
But once you do that, then to the extent that your languages match the system languages, you'll get something that matches the system language. And if the system is something that you completely don't support, then it will fall back to your ultimate fallback language. The other thing is, although we add these lip languages, the lip languages, I should have talked a little about extensive localization. We have partial languages which fall back to another language. Those are still system languages. There's another category of partially localized language called a lip language. A lip language is smaller than even a partially localized pack, covers maybe 20% of the resources but 80% of the visible UI, but that must be installed on top of one of our base 36 languages. So you can be sure that one of our base 36 languages will be on the system, even if most of the UI is showing up in one of the lip languages.
Okay. And the second question which I had was the user language. If I go into control panel in regional settings, I find it as the display language, user display language.
Yes.
What is system language? Is it always?
So there's on the regional options control panel, there's another tab that says apply this to the system accounts, and that's what changes the system language. And there are actually two settings. You can apply it to the default login, the default user, and you can apply it to things that run in the system account. And so things that run in the system account is the system UI language.
And third question which I have seen that a lot of applications, including .NET application, they fall back to the user locale, which is called as date and time format, and which OEM sometimes consider as not a MUI compliance.
Yeah, falling back to locale is risky because we support way more locales than we support languages. And so it's
So the question is like, so if I have my UI language as German and if I select the locale as French,
right.
and all the application come up in French. I mean, everything you see on the application is French.
Right, and that's where we need to. So unfortunately, there's not an answer for that one in Windows 7. So there's not a common place to put a language setting for applications that is not also a system setting. Okay. But applications should be following the system fallback. That's part of the MUI compliance. Is not don't do things like try and guess the language from the locale, but just trust that fully merged list, right? So get that from the operating system. If you need to do something, if you have an override for that, don't go probing around, add it to the list, and then use the list. Because that will get you the consistent behavior for the whole system.
Right, and one thing to mention regarding the locale information itself, when you get the locale information like date formats and so forth, the locale that you pass in, it will be the string that that will come back will be in the language of that locale that you passed. So if you want to get information from the locale, what you want to do is to figure out what's the UI language, and from the UI language, ask to get the locale information from that UI language.
Oh, okay. Okay.
You really do want to keep locale and UI language separate, because mixing the two confuses both of them.
Yeah, applications which were built for XP and before, they always look at.
I know, and that's one of the things we're trying to change. And that's I just got another email yesterday from a pretty major OEM saying, please get this fixed. Right? It's been a problem for a while, and it's becoming more and more of a problem. Right? As more of the processes are shifting over and more of the product lines are shifting over to really shipping multilingual systems. We have one OEM who ships a single image worldwide, all 36 languages installed, that specializes itself post-install, right? And so that's where people want to go, right?
I'm acutely aware of that.
So,
thank you.
Yep. Yeah, Mike, it is in the appendix, so when you get your hard drive, the slides here. But just one more time, my alias is just Eric, E-R-I-K, at Microsoft.com. I have some business cards with me. I forgot to grab the big stack, so I don't have 100. But
so when doing the language detection, do you need to refer to lots of dictionary data? Do you need to refer to lots of dictionary data?
No, you just need to pass to us the text, and we'll tell you the language that we believe that text is written in.
I mean, in your implementation, do you need to look into some dictionary to decide what language it is?
Well, so our component includes all the information that is required. So basically, the platform itself has all the information required to detect that language.
Are you asking how big is that, or
are you asking how big is the data itself?
Yeah, for these all 100 languages.
It's about, I believe, 0.5 meg for all the languages.
Okay.
The whole component.
Our application have already support MUI on Vista. So do we need to do something if it moves to the Windows 7?
No. The one visible change that might make things a little simpler for you, in Vista we had thread language only.
Yes.
Which meant that if you're multi-threaded, you have to remember to set the language on every thread.
Yeah.
In Windows 7, we had the notion of a process language, so that you can set that one time and not have to worry about setting that on every thread. That's one visible change, but otherwise things work pretty much the same as they did.
Thank you. Yep. So there is still not, how to say, deadline for the ELC API release, right?
For the, I'm sorry?
ELC.
The ELS APIs?
Yeah.
I think it's saying LSIDs, right?
Oh, yeah. So we still accept LSIDs, but we strongly recommend language names, and the file names have to be in language names. Is that?
Okay, thank you.
One of the main reasons that you should look into string-based locale names is because as we move forward, we are also allowing you to create your own locales. And we have a tool called Locale Builder. So somebody can create a locale, and then you can create user interfaces based on that, which does not have an LSID at all. And that's why.
Does this also work on WinRE and WinPE?
Yes, from Vista and Win7 and beyond, yes.
Okay, so it works the same way.
Yep.
All right, thank you.
Okay, you just mentioned that you can set the culture for the entire process instead of on each and every thread in the application.
You can set the UI language,
Yeah.
Per thread or per process, or both, right? So I can set a default for the process and still override it on a per thread basis.
Okay. Any chance that will ripple through to a version of the .NET framework?
I don't know of plans to do that, but like I said, we talked to them, so we can certainly.
If you could ask them to do that, that would be really helpful.
Oh, right there. There we go.
So after 4.0, wow. Okay.
I didn't see you sitting there. Welcome. So.
Any services to detect encoding?
So currently, you mean the character encoding?
Yeah, so something is not in.
So if you're not Unicode, how do I?
Right. So there is a very old component that we don't really maintain. It's called mlength. It's very old, and we're trying to move away from it so we can build something that will be better. But the reason for that is basically we would like really for, application developers to really write code in Unicode. Right? We want people to move.
User data is not always.
Yes, understood. You can mention.
Wait. Okay. That's everything. Thank you very much.